Holy heavenly hot dog hamburger. I know that you guys are so thrilled to learn about medians of a triangle because we've already had so much fun learning about other types of segments and triangles that you guys are even more excited to learn about medians of triangles. Well, let's get started on it because I know you guys are ready for it. All right, so we've already talked about what concurrent lines are, but it doesn't hurt to recap what they are. So, we've already talked about several types of concurrent lines. Two being angle bisectors, which are lines that slice through a triangle and it bisects the angle. And we've also talked about perpendicular bisectors, which are lines that slice through a triangle, make a 90-degree angle, and will hit the midpoint because they're bisecting it and slicing in the middle. Okay, so these are concurrent lines because concurrent lines are when three or more lines intersect at one point, which is called the point of concurrency. Which again, we've already talked about some special points of concurrency, including in angle bisectors, the point where the three angle bisector lines intersect is called the incenter. And in perpendicular bisectors, we talked about how when the three perpendicular bisectors intersect, the point of concurrency is called the circumcenter. Guys, so when you have three lines, bam, 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 that all intersect in one point, that point is called the point of concurrency, and the lines are called concurrent lines. Nifty, right? All right, so let's talk about what a median is and how these lines will go through a triangle. So what does the word median kind of sound like? Medians do kind of sound like in the middle. Okay, what is a nifty point we've talked about that's in the middle of a segment? What is that awesome point called? It is precisely called the midpoint. So guess what, you guys? A median, it's a segment whose endpoints are a vertex, so they must start from a point on the triangle. Okay, so at the pointy parts, the parts where if you were to touch it would hurt. You'd be like, ow, that hurts, ow. Okay, so the vertex points, it has to start from a vertex. Okay, and then when it crosses to the other side of the triangle, it's going to hit at the midpoint. So it's a segment whose endpoints are a vertex and the midpoint of the opposite side. So medians have to start from the vertex points. They have to. As well as angle bisectors, which we've already talked about that. Remember, perpendicular bisectors do not have to start from a vertex point, so be careful. Guys, so these start at the vertex point and extend to the other side until they hit the midpoint, which means they're in the middle, and will create two congruent segments. So bam, we got two congruent segments. We got another median, so bam, it creates two congruent segments. And we have another median, and bam, it creates two congruent segments. And guess what, you guys? These are concurrent lines because we have three or more lines intersecting in one point. And guess what, you guys? This point right here is going to be our point of concurrency. Okay, which in a median, it also has a special name. And that special name is the centroid. Guys, so the centroid is the point of concurrency for the medians. Okay, it's called centroid. And this is a pretty cool sounding one. In my opinion, it's the coolest sounding one. Centroid just sounds neat to me. I don't know why. Not that incenter and circumcenter don't sound cool too, but centroid just sounds like something from another planet or something. So it's pretty awesome in my book. But anyways, there's an awesome centroid theorem that we're going to learn about. So, the centroid theorem states that the centroid of a triangle is located at 2/3 the distance of the median. Guys, so the point of concurrency, if you're going along your median, it is 2/3 of the way down from the whole segment. Okay, which these segments start from the vertex. So, you start from the vertex and 2/3 down, bam, you got your point of concurrency, which is the centroid. Okay, so what this means, okay, in order to get the distance from the vertex to in order to get the distance from the vertex to the centroid from each vertex, if you multiply the whole segment length by 2/3, okay, you will get the distance from the vertex to the centroid. So like A to the P, so here to here, to get that length, you multiply the whole segment, the whole median, AY, by 2/3, and that will give you the distance. Okay, and same with the other one. So if you start with any vertex point and extend to the centroid, it is 2/3 of the way down, which is pretty cool. Now, there's another way to think about this, which in my opinion is a little easier. So we know that the distance from the vertex to the centroid is 2/3 of the way down. So if we know that, what is the distance from the centroid to the side of the triangle? 2/3 plus what gives me one segment? So 1. 2/3 plus what gives me 1. Holy hot dog, you guys. It is 1/3. 2/3 plus 1/3 will give you 3/3, which reduces down to 1. Guys, so I prefer to think about it this way. If you know the length of the whole median, multiplying something by 1/3 is the same as dividing by 3. So if I know the whole length of the median and I divide by 3, I will get the distance from the centroid to the midpoint of the opposite side of the triangle. Okay, which, how does 1/3 relate to 2/3? And how does 2/3 relate to 1/3? Like, if I know this piece, what do I have to do to this piece to get the 2/3 piece? 1/3 times what gives me 2/3? Amazing, you guys. It is 2. So if you know the distance from the centroid to the opposite side of the triangle where we hit the midpoint, if you know this distance, if you double it, bam, you'll get this distance right here. Okay? Or vice versa. If you know the distance from the vertex point to the centroid, okay, if you know that, if you divide by 2, because 2/3 divided by 2 is 1/3. If you divide this segment by 2, you will get this segment. So it's a lot of like multiplying by 2 and dividing by 2 if you know what the length of the whole segment is or even a portion of it. So really, instead of thinking about it in thirds, I like to think about it as doubling this piece or dividing this piece by 2. And if you need to know what this little guy is, you divide the whole thing by 3. Okay, which I know I've like way over explained it. It'll make more sense when we do the funsies and do the actual examples. I pinky promise. Okay, so this is what I was explaining earlier. So to get BP, to get this one, if you know the little guy right here, PZ, if you multiply it by 2 or double it, that will give you this length. And vice versa. If you want to know the little guy's length, so P to the Z, if you half the larger piece of the segment, bam, you'll get this piece. So that's how I'm going to be looking at it instead of the 2/3, so I just think it's a little bit easier to understand. But you can still think of it, the piece from the vertex to the centroid, as being 2/3 of the whole line. You can think about it that way as well. It's not wrong, I pinky promise. All right, so example 1 and 2 for medians are going to be so much fun. We're going to be doing both of these based off of this picture, so you'll want to copy down this awesome picture twice when you're solving. So go ahead and pause the video and enjoy example 1 and 2, because I know you guys will have so much fun. I pinky promise. And these are the funsies that we're going to be later, so hold your horses. We'll get to them in a moment. I promise you guys, I promise.